Hello students, today we are looking at class 9 mathematics chapter 7 triangles. In Euclidean geometry, any 3 points when non-collinear determine a unique triangle and simultaneously a unique plane. A unique triangle and a plane. Here in the figure we could see that it has 3 points. Let's name the points A, B and C. We could see that these 3 points are non-collinear. Since they are non-collinear, what can we say? We could say that it forms a unique triangle and a unique plane. A triangle is a three-sided polygon which is sometimes also known as a trigon. Why? Because tri means 3. A triangle has 3 sides, 3 angles and 3 vertices. Let's look at this figure. This figure has 3 sides, AB, AC and BC. It also has 3 angles, angle A, angle B and angle C. And it also has 3 vertices, A, B and C. And we could say that this figure ABC is a triangle. Triangle ABC is denoted as a small triangle with the name. Types of triangle. We could classify triangles on 2 bases. One on its sides and the other on the basis of its angles. First, let's look at the classification of triangle on the basis of sides. Equilateral triangle, isosceles triangle and scalene triangle. Equilateral triangle is a triangle which has 3 equal sides. Let's look at the figure triangle ABC. In this triangle, let's say that the side AB is 4 cm, side AC is 4 cm and side BC is also 4 cm. What can we say from this figure? We could say that side AB equal to side AC is equal to side BC. So all 3 sides of this triangle are equal. Hence, we could say that triangle ABC is an equilateral triangle. Also, in an equilateral triangle, all 3 angles, that is angle A, angle B and angle C, all 3 angles will be equal and it will be equal to 60 degrees. Next, let's look at isosceles triangle. Isosceles triangle is a triangle which has 2 equal sides. Let's look at the figure triangle PQR. In this triangle, let's say that the side PQ is 5 cm, side PR is 5 cm and side QR is 4 cm. What can we say? We can say that the side PQ is equal to side PR, but it is not equal to side QR. And from this figure, we could see that when 2 sides are equal, we could say that the triangle PQR is an isosceles triangle. Scalene triangle. Scalene triangle is a triangle which has no equal sides. Let's look at the figure triangle DEF. In this triangle, let's say that the side DE is 4 cm, side DF is 5 cm and side EF is 6 cm. Here we could see that the side DE is not equal to side DF and is not equal to side EF. All 3 sides are not equal. Hence, we could say that the triangle DEF is a scalene triangle. Now, let's look at the classification of triangle on the basis of its angles. We have acute triangle, obtuse triangle and right triangle. Let's look at each of them in detail. Acute triangle is a triangle which has 3 angles less than 90 degrees. Let's look at the triangle LMN. In this triangle, when angle L is less than 90 degree, angle M is less than 90 degree, and angle N is less than 90 degree, all three angles are less than 90 degree, then we could say that the triangle LNM is in what triangle? Acute triangle. Next, let's look at obtuse triangle. Obtuse triangle is a triangle which has one angle which is greater than 90 degree. Let's look at the triangle STU. In this triangle, we could say that angle T is greater than 90 degree, but angle U is less than 90 degree and angle S is also less than 90 degree. Here we could say that one angle is greater than 90 degree and the other two is less than 90 degree. So we could say that triangle STU is an obtuse triangle. Right triangle. Right triangle is a triangle which has one angle exactly equal to 90 degree. In the figure XYZ triangle, we could see that angle Y is equal to 90 degree. Angle X and angle Z both is less than 90 degree. So in a triangle where one angle is 90 degree and the other two angles are less than 90 degree, we could say it's a right angle triangle. So triangle XYZ is a right angle triangle. Now we'll be looking at the properties of triangle which we have already learnt. Theorem 6.7 states that the sum of the angles of a triangle is 180 degree. So in any triangle, when you add up all three angles, you will get 180 degree. Let's look at an example. Here we could say that in triangle ABC, by theorem 6.7, what are the three angles in this triangle? A, B and C. So we could say that angle A plus angle B plus angle C equals 180 degree. This will be applied in any triangle. Means it is called as angle sum property of a triangle. Next, let's look at theorem 6.8. It states that if a side of a triangle is produced, then the exterior angle so formed is equal to the sum of two interior opposite angles. Let's take triangle DEF. In triangle DEF, when one side of a triangle is produced, then the exterior angle so formed, so the exterior angle formed here is DFG, is equal to the sum of the two interior opposite angles. What are the two interior opposite angles here? Angle DEF and angle EDF. Thus, the exterior angle will be the sum of two interior opposite angles. This can be proved by theorem 6.8. Congruent figures. Congruent means equal in all respects of figures whose shapes and sizes are same. We could say that a pair of shapes are congruent if they are equal in all respects, that is sides and angles. Let's look at these two squares. We could say that these two squares are congruent if both their sides are equal. We know that the squares' angles will also be equal. So, since all of their sides are equal, we could say that these two squares are congruent. Similarly, in this hexagon, let's say that the first hexagon has each side 2 cm. And the second hexagon also has each side 2 cm. Now, we could see that both these hexagons are equal in every aspect. Thus, we could say that these two hexagons are congruent. Now let's look at the congruence of triangles. In a pair of triangle, if all three corresponding sides and the three corresponding angles are exactly equal, then the triangles are said to be congruent. Let's look at these two triangles. Let's say the first triangle is P, Q and R. And the second triangle is A, B, C. In triangle PQR, side PQ is 2 cm, side PR is 3 cm and side QR is 4 cm. Also, angle P would be 40 degrees, angle Q would be 60 degrees and angle R would be 80 degrees. Now in triangle ABC, let's say that AB is 2 cm, AC is 3 cm, BC is 4 cm, angle A equals 40 degrees, angle B equals 60 degrees and angle C equals 80 degrees. Now let's compare the triangle PQR and ABC. First, let's take the sides. In comparing both the triangles, in triangle PQR and triangle ABC, first the sides we see that PQ is equal to AB. Yes, because both are 2 cm. And we could say that side QR is equal to side BC. And we could say that side PR is equal to side AC. Why? Both are 3 cm. Now looking at the angles, we could say that angle P is equal to angle A, which is 40 degrees. And angle Q equals angle B, 60 degrees. And angle R equals angle C, 80 degrees. So comparing these two triangles, we could see that all three corresponding sides and all three corresponding angles are equal. Hence, we could say that these two triangles are congruent. If triangle PQR is congruent to triangle ABC, we could write it like this. In congruent triangles, CPCT, that is, corresponding parts of congruent triangles are equal. Criteria for congruency of triangles. Axiom 7.1 talks about the SAS congruency rule. SAS congruency rule stands for side, angle, side. Two triangles are congruent if two sides and the included angle of one triangle are equal to the two sides and the included angle of the other triangle. Let's say that in triangle ABC and in triangle PQR, side AB is equal to side PQ and side BC is equal to side QR and angle Q is equal to angle B. Here we could see that two sides of two triangles are equal and their included angle is also equal. Thus we could say that triangle ABC is congruent to triangle PQR. SAS congruency rules holds but not AAS or SSA. Side, angle, side congruency only holds. Angle, angle, side or side, side angle is not applicable for proving congruency. Theorem 7.1 AAS congruency rule. Two triangles are congruent if two angles and the included side of one triangle are equal to the two angles and the included side of the other triangle. In triangle ABC and in triangle PQR, if side AC is equal to side PR, angle A is equal to angle P and angle C is equal to angle R, we could see that two angles are equal and one included side is equal. Thus, by ASA congruency rule, we could say that triangle ABC is congruent to triangle PQR. Thus, AS congruency rule stands for angle, angle, side. Now let's look at AAS congruency rule. Two triangles are congruent if any two pair of angles and one pair of corresponding side are equal. In triangle ABC and triangle PQR, if angle A is equal to angle Q, angle C is equal to angle R, and side BC is equal to side QR, we could say that two angles, angle and side. Thus, angle, angle, side. By AAS criteria, now we could say that triangle ABC is congruent to triangle PQR. Let's look at some properties of triangle. Theorem 7.2 states that angles opposite to equal sides of an isosceles triangle are equal. Let's take an isosceles triangle ABC. Angles opposite to equal sides of an isosceles triangle. What is an isosceles triangle? A triangle which has two sides equal. So in this isosceles triangle, let's say that side AB is equal to side AC. By theorem 7.2, we could say that the angles opposite to equal sides are equal. That is, the angle opposite to side AB, that is angle C, and AC, that is angle B, are equal. Thus, by theorem 7.2, since AB is equal to AC, we could say that angle B is equal to angle C. Theorem 7.3. The sides opposite to equal angles of a triangle are equal. This is the converse of theorem 7.2. Here we could say that since angle B is equal to angle C, thus we could say that AB equals AC. Let's look at some more criteria for congruency. Theorem 7.4. SSS congruence rule. If three sides of one triangle are equal to the three sides of another triangle, then the two triangles are equal. In triangle ABC and in triangle PQR, side AB equals PQ, AC equals PR, and BC equals QR. Here we could see that side, side, and side. Three sides are equal. Thus, by SSS congruency rule, we could say that triangle ABC is congruent to triangle PQR. Theorem 7.5 RHS congruence rule. Here, RHS stands for right angle, H stands for hypotenuse, and S stands for side. If in two triangles, the hypotenuse and one side of a triangle are equal to the hypotenuse and one side of the other triangle, then the two triangles are congruent. In triangle ABC and in triangle PQR, both these triangles are right angles at angle B and at angle Q. Also, side AB is equal to side PQ and the hypotenuse AC is equal to the hypotenuse PR. So, right angle, hypotenuse and side. Thus, by RHS congruence rule, we could say that triangle ABC is congruent to triangle PQR. Inequalities in a triangle. Let's look at theorem 7.6. Theorem 7.6 says that if two sides of a triangle are unequal, the angle opposite to the longer side is larger. In this triangle ABC, let's say that AB side is 4 cm, AC is 5 cm, and side BC is 6 cm. The longest side in this triangle is side BC because it's 6 cm. The angle opposite to that is angle A, will be the longest, largest or greatest angle in this triangle. Why? Because it's directly opposite to the longer side. Thus, by theorem 7.6, in triangle ABC, angle A will be the largest angle. Theorem 7.7 is the converse of theorem 7.6. It states that in any triangle, the side opposite to the larger or greater angle is longer. So, the side opposite to angle A will be the longest. So, BC side will be the largest side in this triangle. Theorem 7.8. The sum of any two sides of a triangle is greater than the third side. In any triangle, we know that a triangle has three sides. When you add any two sides of the triangle, it will always be greater than the third side of the triangle. Let's look at an example. In triangle ABC, let's say that side AB is 6 cm, side BC is 7 cm, and side AC is 8 cm. For instance, let's add side AB and side BC. 6 plus 7 get 13 cm, which 13 cm is greater than 8 cm. So in any triangle, always when you add two sides, it will be greater than the third side. Let's look at what we have learned in the chapter. We first started by learning about triangles. We looked at some of the types of triangles and some of its properties that we have learned previously. We learned newly about congruency of triangles in this chapter. And we learned few criteria for congruency. We also learned about few inequalities of triangles. That's it for this chapter. I hope you all understood. Thank you.